How are you, my friends? This is lecture number 36 of the pre-calculus course, Properties of Determinants. You can see the other lectures on the playlist down here. Please, you can review lecture number 35 on determinants of matrices. It will help you to understand better this lecture number 36. Now, at the end of this lecture 36, you will find some old exams questions to practice on both lectures. Now, here we have 9 determinant theorems to help you evaluate the determinant easily. Let's see, I will go one by one. Number 1, if every entry in a row or column of a matrix A is 0, remember every entry, then the whole determinant is 0. That's so simple here. An example, 63 minus 8, 0, 0, 0, 4 minus 7, 0. That will be, determinant will be 0. Because if you choose here row 2, and then you expand to find the determinant, you will get 0. Please, you can review lecture 35 to understand the method. If 2 rows or columns of a matrix A are identical, then the determinant of A is equal to 0 also. So if we have like 6 minus 2, 1, 6 minus 2, 1, and here 0, any number there, 0, 5, 6 or something. See, these two, if you expand, it will be also the determinant 0, because we'll see later now, if you multiply with the minus 1 here, and then you add to row 3, it will be all zeros like rule number 1. Okay. If the rows of a matrix A are the corresponding columns of the B. So if we have an A like this, just a matrix, remember here, and we take the rows, see the rows here, like n minus 3, this is a row. I make it here a column, and then a row here, 4m, I make it a column here. That's another matrix B, and this is A. They have the same determinant. So determinant of B is equal to determinant of A, or determinant of A is equal to determinant of B. That's rule number 3 in this sequence. Number 4, if any 2 rows or columns of matrix A are interchanged, 2 rows or 2 columns, to form matrix B, then the determinant of the new one, B, will be minus the determinant of the A. Look at this easy, nice example. If we have ABC here, EFG, HIJ, the determinant here, any numbers there, the determinant is 7. So what did I do here? I take ABC from row 1, I put it here in row 3. And then HIJ from row 3, I put it in row 1. So I interchange 2 rows here only. EFG stays there, so the determinant will be minus 7. Every time, guys, you interchange 2 rows, put a minus in the answer, or you interchange 2 columns, put a minus. Now, number 5, if matrix P is formed by multiplying every entry of a row or column of matrix A by the real number K, then the determinant of the B is K times the determinant of the A. Let's take an example here. If the determinant of ABC, EFG, HIJ is equal to 7, let's find the determinant of EF, 2G, AB, 2C, 3H, 3I, 6J. So the idea here, I have to look at the required, at the question, and compare it with the given. I see ABC here in row 1, it is now in row 2. So there is a minus because I interchanged row 1 and row 2. Remember here, HIJ stayed in row 3. Now, row 3 is multiplied by 3, so this is the K here. See, if K is multiplied in a row or a column. So we have 3 multiplied by row 3. So they have put 3 here. 2 and 2 there, multiplied by column 3. So we have a 2 there. And then the 7 from the determinant of the given. So when you multiply, you get minus 42. Now we have reached the theorem number 6, determinant of product. Determinant of A times B will be the determinant of A times the determinant of B if each one is defined. Now, number 7, changing a row or column of matrix by adding to it a constant times another row or column does not change the determinant. Not easy to understand from the first time. Let me explain it with an example. A, B, C, E, F, G, H, I, J, this is determinant, is equal to 7. If I take row 1 here, see, I multiply by 2, which is a constant, positive or negative. I multiply by 2, then I will add to row 2. So it will be ABC will stay there, E plus 2A, F plus 2B, G plus 2C does not change the value of the determinant. Also, if I multiply row 1 or any other row by any number, positive or negative, and then I will add to another row. So I will say here H minus 3A. So the number here, the constant is minus. Here the constant is plus, but it's all adding. This is like H plus minus 3A, I minus 3B, J minus 3C. Does not change the value of determinant. It will be 7 again. So we call this row or column transformation. We will use this a lot in the examples. Number 8, the determinant of the inverse. This is so nice. Determinant of the inverse is the reciprocal of the determinant of A. So nice to know that. So if we have, this is matrix A, and this is the inverse of that. The determinant of the inverse, 1 over the determinant of A. We can use it also in some examples. This is the most important. If A is written in a triangular form, upper or lower, then the determinant of A will be the product of entries on the main diagonal. This is so nice. If we can write any matrix, this is A, 3 by 3, 4 by 4, 5 by 5, 10 by 10, triangular. See, triangular like triangle, upper or lower. If you have a triangle here, all zeros down. Or you can have zeros up, upper or lower. This is upper, triangular. You have all zeros under the main diagonal. Then the determinant of the A will be the product. 5 times minus 2 times 7, which is minus 70 easily. So you can use all these theorems together to make it easy to find the determinants. Remember, this is a matrix. You see the square brackets, and this is 2 vertical bars. That's the determinant minus 70. Let's start with the examples. Find each determinant. You can take a minute to try each one. 2, 3, 0, 1 minus 7, 0, minus 5, 9, 0. That's so easy. Here the determinant is equal to 0 because we have theorem number 1. Okay, so this is theorem number 1. We have elements in column 3 are all zeros. So directly column number 1, this is a 0. Now let's see number B, example 6B. You have to work with the rows here. So let me change. If 2 is there, leave it. Let me try to make some kind of triangular. Use determinant theorems or anyone. Theorem number 7 says you can use twice here. Multiply. See, this is 6 here. Just multiply by minus 3, row 1. Add to row 2. Nothing will change here. See, the determinant of this is the same determinant of this because we multiplied row 1 here by minus 3. See, minus 3 here, 6 becomes minus 6, 0. Minus 3 times minus 1 plus 4, this is 7. Minus 3 times 3 is minus 9 plus the 10 is 1. Then I can multiply, this is 2 and this is 4. So I multiply by minus 2 on the row 1. You add to row 3, you get 0, 7, 1. So I have used Theorem number 7, twice. This is rows transformation. Now, I can see two identical rows, or I can multiply again by -1, and then I will add to row 3. So the whole determinant is 0. See, it does not look, it's a 0, but the determinant is 0. This is a little tricky question. Now, we have a matrix now. See, T is a matrix, A, B, C, X, Y, Z, M, N, K. This is a T, 3 by 3 matrix. The determinant itself is -3. Let's find the determinant of what? 2 times this determinant and determinant of 2t. See, these are different questions. 2 outside times determinant of this. You see what are the changes that you can see the other examples to compare. And here we need the determinant of 2t. T is a 3 by 3 matrix. You multiply it by 2 first as a scalar, and then you find the determinant after you multiply by 2. They are different. So be careful here in example. See, this is example 7. Be careful. If you multiply 2 times the determinant, this is not correct here. Because this determinant, 2 vertical bars, that's a number times 2. You cannot include the 2 inside here. But this is true. 2 times the square brackets, that's a matrix. See, just a matrix. So 2a, 2b, 2c, 2x, 2y, 2z, 2m, 2n, 2k. This is true, and this is not true. All right. So let's see 7a. 7a, this is determinant is -3. It's given. So I have to see the changes here. X, Y, Z, and ABC are interchanged. You see ABC in row 1 now. It is here in row 2. See, this 2 will stay in the answer. It will affect nothing on the question. This 2 will stay there. Okay, so there is an interchanging here 2 rows. This is theorem number 4. So that's a -1. See, theorem number 4. And now, in the row 3, we multiply by 5. So that's theorem number 5. Multiply here by 5 on row 3. And this is the given here. The determinant is -3. So the answer here is 30 for this. Now, if you look, this is more tricky. B part, more tricky. The determinant of 2t. We know the t is the square matrix, so I multiply each element by 2 inside. Then I take the determinant, remember. So this means that I multiplied row 1 by 2, multiplied row 2 by 2, multiplied row 3 by 2. So there are 3 times. So I have used theorem number 5 3 times, applied on row 1, row 2, and row 3. So this is like 2 cubed. So if k is 2, here k is 2, 3 times. So this is 2 cubed. The value is 2. We can multiply by 5, by 6, by -half. 2 cubed times the determinant of the t, which is the given -3. So the answer is -24. Now, this is a really nice example, number 8. Rewrite the determinant in a triangular form, then find the value of each determinant. Look at C and D. There are 2 parts. What do you notice, guys, here? So easy to notice something. In C part, it's already written in triangular form. See, if you make a triangle here, all zeros under the main diagonal. But this one is not. This is ready. C is ready. D is not ready. So we can make it ready. We can make zeros under the main diagonal or zeros above the main diagonal, the same determinant we can get. So if we look at C, see here, we see it's ready. See, this one is ready. 3 minus 7, 4 and 10, and 1 here on the main diagonal, -5 in the main diagonal, 6 in the main diagonal, and here we have zeros under. So to find the determinant, just multiply 3 times 1 times -5 times 6. It will be -90. Now this one is not ready. We can put it in triangular form. So I start with here. I leave this 2. It can be any number, 1 or 5 or 7 or half, positive or negative. I need these zeros. I'm trying to make all these numbers, this 2, 4, 2, 5, 2, and 6. I'm trying to make all these zeros so that I can find easily the determinant. So I will apply theorem number 7 3 times. This is Rowe's transformation. So I multiply -1 because see the opposite of this is minus, the opposite of 2 is -2. So I multiply with -1. Then I multiply with -2 to change this 4 to 0. Then I multiply with -1 to change this number. One time here I can use 3 steps in one. So 2, 1, -1, 3. Row 1 will stay. This will be changed into 0, 1, 1, -2 because I multiplied -1 times all row 1, then I will add to row 2 here. You can do that. -2 times all row 1, I will add to row 3. You get 0, 3, 6, -9. -1 times row 1. You can do it yourself easily. Multiply and then add to row 3. You get 0, 1, 7, -6. See, now this one is 2. This is all zeros. I can leave the 1 here. Then I have to change 3 and 1. Now I can see from the previous slide that I have to change these numbers under the 1, 1, 3, 1. I have to change this number to 0, this number to 0. So I multiply row 2 now. I use row 2. Finish row 1, I don't touch again. So -3 times row 2 here plus row 3. So let's do that. -3 times 1, -3 plus 3, you get 0 there. -3 times 1, -3 plus 6, you get 3. -3 times -2 is 6, and -9 will be -3. Then you multiply row 2 by -1 again, -1, and then you add to row 4. So that will be 0, that will be 6, and that will be -4. So the only thing we have to change now, change this 6 to 0 to have upper triangular. So we can use theorem number 7 one time. We call it row transformation. And then I multiply row 3, see row 3 here by -2. Directly I will add to row 4 to make it 0. So -2 times 3, -6 plus 6, 0. -2 times -3, 6. You add to -4, you get 2. So now we have 2, 1, 3, 2. And we have all zeros under the main diagonal. So this is triangular form. And the determinant that we need is 2 times 1 times 3 times 2, which will be 12. Example 9 is really also nice. A and B are matrices 3 by 3. Determinant of A is 6, determinant of B is 5. Let's find the determinant of AB, -1/3 determinant of A plus determinant of 2B. Now be careful about this. You multiply the matrix B by 2 first, then you find the determinant. Now, the first one, we can use theorem number 6, which is determinant of A times determinant of B. This one is easy, -1/3 is outside. This one, theorem 5, this is 2 cubed, because we have 3 rows and 3 columns. So we'll multiply the 3 rows. So 2, 2, 2, it will be 2 cubed times the determinant of the B. You can check that, please. So now we have 6 times 5 minus 1/3, and this is determinant of A is 6, so 6/3 plus 2 cubed, and determinant of B is 5 given. So that's 30 minus 2 plus 40, 68. Now, in this lecture 36, you can find, please, 2 parts to practice on the questions. Part 1, there are 4 questions. I will show you now the questions. There is one video that shows all the solutions of this part. Part 2, 7 old exams questions. Also another video will show the detailed solution. This is part 1, 4 questions. So this is question number 1. Given a matrix A 2 by 2 that has sines and cosines, and we need 12 times the determinant of A. Try it. This one, let's find the value of the x. If the determinant of this matrix M is equal to -3. Determinant is equal to -3. This is E 2 by 2, 2 minus 130. If the determinant of E minus ln of x times I is equal to 18, find all values of x. This is not easy, but so nice and interesting. And this one has all kind of log, ln, tan inverse, cosine pi, log of 10. So we have matrix A 2 by 2, matrix B 2 by 2. Find the value of the x if the determinant of A plus the determinant of B is 78. So I can tell you the idea. Simplify A, simplify B. Find the determinant of A, put it there. Find the determinant of B, put it there. Add whatever you can add, combine like terms, equal 78, make an equation, find x value. These are the answers here. And then 7 old exams questions as usual on the determinants. This is question number 1. Find the values of the x in these equations, A and B. Find the value of M13 plus C32. This is minors and cofactors, remember? You can go to the lecture and check. Solve the equation. We have the determinant is equal -3. Now question number 4, given A, we have here 3 by 2 and B is 2 by 3. We need the value of the determinant of BA. Please check the idea here and find the answer. Question number 5, there's a good idea here because this question combines the determinants and the inverses and the matrix here. 3x2 minus 1 is A. The determinant of the inverse -1/15. Find the sum of all elements or entries or members of A inverse. Question number 6, if x and y are 4 by 4 matrices such that the inverse of x exists, the determinant of A is equal to 3, the determinant of y is equal to 2, find all this value. You can check it. And question number 7 is really nice. Find the sum of the following if possible. I will leave it for you to read it carefully and find the answer in A, find the answer in B. And here are the 7 answers of the old exams questions. For complete solution, please, you can see the video on determinants of matrices, lectures 35 and 36, pre-calculus old exams questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is pre-calculus course, lecture number 36. We are reaching the end of the course, which is lecture 40. I wish I can see you in another video with another topic. Thank you very much for listening.